Good morning, my wonderful students. This is another episode coming to you courtesy of Landmark Tutorial Center. Now, in the previous episode, we have discussed about the rotational dynamics of rigid bodies, where we considered the equivalence of mass, where we talked about moment of inertia, we talked about the kinetic energy of rotation. Whereby we said that when a body is rotating, that body is actually having its own kinetic energy. When a body rotates, it rotates with a particular speed, which we call the tangential speed or the tangential velocity. And this velocity is normally tangential to the circular part of rotation. But today, and we also seen that we can calculate the moment of inertia. I told in the last class that every object has its own formula for finding its moment of inertia. And we're able to derive the moment of inertia of different objects through their center of gravity. For example, we said that if you are given, if I have a ring, this is a ring, this is a ring. We observe that the moment of inertia for a ring is given as what? As m arrow squared. Where this our r has to do with what? The distance, that is the radius of the circular part. So then that is, we have found the moment of inertia of a ring through the center of gravity. Maybe if we have here as the center of gravity, and you wish to rotate this ring about this axis I have chosen. That is this axis that is perpendicular to the board I chose here now. So when you rotate this now, we can easily find the moment of inertia about this axis that passes through the center of gravity. And it is found as as m arrow squared. In the same vein, if I am giving something like a disc has its own moment of inertia. We observe that the moment of inertia of a disc through the center of gravity is given as as 1/2 m arrow squared. So we get so many formulas for calculating the moment of inertia of different objects. But what if now, instead of asking us to find the moment of inertia about an axis, an axis through the center of gravity, we are now required to find the moment of inertia about another axis through another point, not actually through the center of gravity. I have my instructional materials here. Now look at this rigid body. Now if I want to rotate this rigid body, I may decide, of course you can see the center, this is the center of gravity. So I may decide to rotate this rigid body through this center of gravity by making a hole at this point and then choosing my axis to be along the y-axis. So therefore, I can easily rotate this body like this. It can be in this way, or I can decide to rotate it in this way. So of course, for this body now, I can easily find the moment of inertia about about this axis through this center of gravity. In another way round, I may also be tempted to make a hole at this point, which is different from this one made at the center of gravity. And I may equally want to rotate this object through this axis made at this point. Through this axis made at this point. So of course I can easily rotate this. But now, what if we have a material and we are given the moment of inertia about the center of gravity? We are given the moment of inertia through an axis, or about an axis through the center of gravity. And then we are now required to find the moment of inertia of this same material about an axis which is parallel to the axis through the center of gravity. You can see here these two pens, the red one passing through the center of gravity and the blue one passing through the other point. These two axes, they are parallel. But the only thing is that the two axes are separated by a distance of let's say d or whatever. So in this case, how can we find the moment of inertia through this axis when the moment of inertia about an axis through the center of gravity is given? That is what the parallel axis theorem helps to explain. The parallel axis theorem tells us that it is possible The story about this parallel axis theorem, what it is just saying is that it is possible to find the moment of inertia of what? Of any object through any axis. Parallel to the what? Parallel to the axis about the what? About the center of gravity. So once you know the moment of inertia through the center of gravity, you can find the moment of inertia of that object about any other what? Point. Now to demonstrate this, let us assume that we are given what? We are given an object like this. Let's say a disk. Let me use a disk. We have a disk. And then I'm able to make a hole. Let's have the object this way. All right? And I'm able to make a hole through the center of gravity. The center of what? Gravity. So by so doing, I can draw an axis. This is my axis. This axis now is the axis. The axis through the center of what? Gravity. So I can easily what? Rotate this object in this direction. Therefore, I can find the moment of inertia about this axis through the center of what? Gravity. So this is an axis that passes through the center of what? Gravity. So assuming I have another point, this is another point here, okay, and I make another hole here, and then I have an axis, another axis. Let me call this axis. Let's call this axis as A. We'll have this axis as A and this axis as what? As C. It is also possible for us to find the moment of inertia about this axis A. Let's assume that this axis and this axis is actually separated by a distance of what? Of D. So what is this law or this theorem saying? If you are asked to state the parallel axis theorem in the exam hall, you can say, state the parallel axis theorem and what is its usefulness. I have said that the parallel axis theorem is used to find the moment of inertia about an axis that is what? Parallel to the axis, that is parallel to the what? Axis through the center of gravity, separated by a distance of what? Of D. That is what the theorem says. The moment of inertia, that is the parallel axis theorem states, I repeat, the parallel axis theorem states that what? That the moment of inertia through the what? Through any what? About any axis, which is what? Parallel to the axis, passing through the center of gravity, separated by a distance of what? Distance of D, can be found when the words, when the inertia through the center of gravity is what? Is given. So therefore, the parallel axis theory states that, what? That the inertia through any axis, or about any axis, is equals to the inertia through the center of gravity plus the mass of the object or the rigid body multiplied by the what? By the square of their distance of what? Separation. Please remember, this theorem, this law can only be used to find the inertia about any point. Given that this axis A and this axis C are what? They are parallel. If they are not parallel, then the parallel axis theorem cannot be used to find the inertia about any what? Any axis. So we only use it when the two axes are what? Parallel. That is, the axis through A is parallel to the axis through the center of what? Of gravity. So this is what we do. So immediately you know the moment of inertia about the center of gravity, you can find the moment of inertia about any what? About any point. So we are going to solve series of problems in this dimension and see how these things can be used to simplify our problems in the world of rotation. So we have an example here. I have example what? Example. All right, so this is the question we have on the issue of what? Of the use of the parallel axis theorem to solve problems of finding the moment of inertia through about an axis that is parallel to the axis through the center of what? Gravity. Now let us see if it is possible to use the parallel axis theorem to solve this problem. The question says that a uniform disk, disk, has a mass of what? Mass of 4 kg. Remember, in any question you are solving in physics, as you read the questions out, try to do what? Extract the parameters you have in the question. So the first parameter I have here is the what? The mass. And what is the value of the mass? 4 kg. So, solution. So I have my mass, M. The mass of the disk is 4 kg. And what again? I am given the radius. Radius R is what? 2 cm. But this radius is not in fundamental or standard units. So I have to convert this. If I convert 2 cm to meters, I have it as what? 2 times what? 10 raised to the power what? Minus 2 meters. Then what again do I have? All right. Now we are now required to do what? To calculate the moment of inertia about an axis that is perpendicular to its plane. About an axis that is perpendicular to its plane, which passes through its center. That means in this case, we want to find the moment of inertia. We want to calculate the moment of inertia of this disk through about an axis that passes through its center of gravity. So let us just make a little illustration about this problem. Now, if I have a disk, assuming this is the disk, let me draw it again. I have a disk, and I make a hole at this point called the center of what? Of gravity. And from this point now, I will have my axis. Now, assuming I want to rotate this disk about this axis in this direction, at least I want to rotate it like this. Rotate it this way. Okay? Now, we can find the what? The inertia, moment of inertia, through this center of what? Of gravity. Remember, this object have mass. What is the mass given? 4 kg. And what is the radius of this disk? The radius was given to us as what? As R equals what? 2 by 10 raised to the power what? Minus 2 what? Meters. If you want to find the moment of inertia of any object through the center of gravity, two things are needed. What are those things? Number one, we need the mass. Number two, we need the what? Maybe the radius or the distance of that mass from the what? From the point of what? Of rotation. So these two things are given to us here. So everything is good to go. So let's now see how we can solve this. Now remember, we have given the formula for a disk. This object is a disk. When you want to find the moment of inertia of a disk about an axis through the center of gravity, it has a formula. Who can remind us of the formula? Very simple. The formula we gave was that what? The inertia I through the center of gravity is equals to what? Half m arrow what? Arrow squared. So therefore, the inertia in this case now through the center of gravity, as we are asked to solve in problem 1, will now be equals to what? Half times the mass given to us is what? Is 4 kg times our radius is what? 2 times what? 10 raised to the power what? Minus what? 2. Everything what? Everything squared. I believe this half 2 can cancel this 4. We have 2 remaining here. So our inertia through the center of gravity is now 2 by 4 by 10 raised to the power minus what? 4. Well, if you are wondering how I got this, very simple. I only apply the law of indices here. That the law, this index here, will affect these two factors we have in this bracket. So when 2 is now being squared, it becomes 4. And when 10 raised to the power minus 2 is now being squared and multiplied by 2, we have it as what? As minus what? Minus 4. So this now implies that what? That the moment of inertia through the center of gravity will now be equals to 8 by 10 raised to the power what? Minus 4. Who can tell me the units? The unit of what? Of inertia. Remember, inertia is equals to what? The sum of the what? Of the products of the mass and the what? And the distance of the mass from the point of what? Rotation. So therefore, since inertia has to do with inertia equals what? Is equals to the mass times what? The distance of what? Of the mass from the center of gravity. That is inertia equals m arrow squared. So m here stands for mass, which is measured in kg. R here stands for distance, which is measured in what? Meters. So the unit of inertia will be equals to what? Kilogram meter what? Squared. We can have this as kilogram meters and what? And squared. So this is the answer for this question number what? Number 1. Now, one thing that might be somehow confusing to students is this statement that is made here. because they were asked to calculate the inertia, that is the moment of inertia, about an axis which is perpendicular to its what? Plane. Now, if I have this object here, look at this ruler. This is the ruler. Now, this is the plane of this ruler. This is the plane of the what? Of the ruler. All right? And I made a hole here, and this is an axis. This axis is through the center of gravity. Can't you see that this axis I have made here, or this axis here, is perpendicular to this plane? They meet at angle of 90 degrees. Look at it. They meet at angle of what? 90 what? Degrees. So, but what we are concerned about is that we want to calculate the moment of inertia through the what? About this axis which passes through the center of gravity. And for this object called a disk, the inertia through the center of gravity is given by the formula 1/2 mr what? Squared. That is what we use in solving this question. We now have to solve the second part. Now, in the second part now, we want to find the inertia through a point. The first one we solve what? The inertia through where? Through the center of what? Gravity. The second one now is the what? Is the inertia through a point of its what? Circumference. The circumference of what? Of a disk. So the circumference now is talking about any of these points we have along this arc. It can be here. Okay, let us take it here. This is the circumference, one of it. So if I make a hole at this point now, and of course, through this hole, I draw an axis. I now want to rotate this object through this axis. Let me clean the board so I can now give a proper demonstration of what I'm actually saying. All right, so I have my disk. This is my disk. This is the center of gravity, C. This is the axis through the center of gravity. And I have the initial rotation was done through this axis. And I can now find my moment of inertia about this axis. It was given as half mr what? R squared. Now, I now want to make a hole here. I made a hole at the circumference. And from this hole, I draw another axis. You can see that this axis, let me call this axis A. And this axis now is parallel to this axis. So since this axis and this axis, they are parallel, and they are now being separated by a distance. A distance of what? Distance of d. Therefore, it is possible for me to find the moment of inertia about this axis A by using the parallel axis theorem. So you have to remember what the parallel axis theorem tells us. It tells us that once you know the inertia through the center of gravity, you can find the inertia about any other what? Axis that is what? Parallel to the what? To the axis about the center of gravity, separated by a distance of what? Of d. Now, what we need here is the value of this d. Remember that this disk has a radius. This radius was given to us as r, and the value of r was given to us as maybe 2 cm as we had. But look at this. You can see that from this diagram here, the distance from here to here, which is d, is the same thing as distance from here to here, which is r. So this distance of separation is the same thing as what? The same thing as r. Now, what I'm just trying to say is that we can find the inertia about this axis by using the parallel axis theorem. And what gives us the mind? What gave us the mind was because what? Because this axis and this axis are what? Parallel. And they are separated by the what? By this distance d. So therefore, we have the right to use the parallel axis theorem. And what does the parallel axis theorem say? The parallel axis theorem says, can I say, using the parallel axis theorem. The parallel axis theorem. And this theorem tells us that what? That the inertial about this axis A is equal to the inertial about what? About the center of gravity plus what? The mass of the object times what? Times the square of their distance of what? Separation of the two axes given to us. So here I have the mass of the object as 4. The mass was given to us as what? 4 kg mass. And our radius is given. So now watch. The inertial about the axis A will now be equals to, remember I have given inertia to the center of gravity as 1/2 mr squared. That is half mr what? Squared. So this now becomes half mr squared plus the mass again, m times the distance of separation. Please take notes. where this d is the same thing as r. I have given the reason for that. This now becomes, instead of writing d, I can now put arrow what? Arrow squared. Because this distance here is the same thing as this distance here. So now, this now implies that the inertial about the what? The axis A will now be equals to half m arrow squared plus m arrow what? Squared. This is very simple now. You can see when you add half, this parameter here, this thing here and this thing here, they're the same thing now. So when you add half and 1, this one is half of this plus 1. Half plus 1 will give us 3/2. So this now means that the inertial about what? About the axis A will be equals to 3/2 m arrow what? Squared. For those who understand what we are saying, this is half. Just like when you want to say x plus 2x, it will give us 3x. If I say half x plus x, it will give us, because this is half. Half plus 1 will give us half. 1/2 plus 1 will give us 3/2. That becomes 3/2 what? X. So in the same vein now, half of this plus this, one of these will give us this. So I have the mass, I have the radius. I can now proceed to finish up the work. So this now means that the what? The inertial through where? Let me say the inertial I sub A will now be equals to 3/2 times, what is the value of the mass? 4 times, what is my R? 2 times 10⁻⁻² in meters, or what? Square. So this now means that the inertia about A will be equals to 3/2 times, okay, these 2 can cancel this 4, that becomes 2. 3/2 is what? 6. By, when you take the square of this, 2 squared give us 4 times 10⁻⁻4. And that means that inertia through A will now be equals to what? 24 times what? Times 10⁻⁻4. And what is the unit of inertia again? Kilogram meter what? Square. Please remember, after solving a question in physics, you must make sure that you put the units of the what? Of that parameter you have calculated. So you can see how easy it was for us to find the inertial about this axis, given that we know the inertial about the center of what? Gravity. It is very simple. And what helped us here was what? The parallel axis theorem. So we are going to solve more problems in the next episode of our lecture. Just keep on subscribing and keep on watching these videos to help yourself in the world of physics, to improve yourself the more. Thank you so much, and God bless you. Thank you.